Welcome. Today we're going to look at designing a kernel filter. Let me see if I have, do I have the, did it get saved? No, it's the Excel sheet, right? We did it in Excel. I guess. So we talked about having this 20-stage pipeline that's going to do kernel equations. So that's what we're going to attempt to do here. I can refresh these files. Syntax there. Okay, so right now I'm trying to do an array input using this package, and we're having a few issues. So we're going to try to play around with it, see if we can get some stuff going. So yeah, it looks like it should work. Let me see. Auto HDL packages. Okay. Illegal subtext. So what? Happy about that? The natural range of standard logic vector. What if we did that? So it's not liking that. Oh, I mean, but where's the standard logic vector of that? Yeah. So we'll just call it a bus array. And over here we're going to say 0 to 8 and 31 down to 0. So we'll just call this a bus package. We'll call this window, or just do t underscore window, or window type. Do coefs, maybe 7 down to now we're gonna do coef. want bus package. Bus package. Numeric. So what do we want to do first? Well, first I want to divide the coefficients. So first we want to save the window. So we're gonna have a bunch of window registers. So let's go window reg 0 and be a t underscore window. Make it a signal. Probably gonna be a few of these going. Do we need a reset? This is a feed forward network, so we don't need a reset. We'll just have a clock. No reset value for anything. And that should be good. Now we want to, we need to save our coefficients into whether they're negative or not. So let's do a few types around. So we're going to do type sign and type value. And this just needs to be a standard logic. Oh. For these windows, I'm gonna need to start saving up. We're gonna just do one color to start with. And then we need a type window 16. And this is going to be double data so we can properly multiply it. Okay, so let's do our first stage. So we're gonna call this so we got a stage 1, and we need a process on the clock. Begin process. Now to be if it's rising edge of the clock, then we want to do a for loop for I. If the for loop. Oh, it's not good at syntax for these. For I in 0 to 7 loop and loop. So here so we're going to deal with everything here. So I'm gonna do I. Quiet. I 0. Going to equal window I. Okay. So next we have T sign. T sign is just gonna be I. And we're gonna do, oh, T sign isn't actually a thing. So we're gonna do signal sign is type T sign and coefficient value. Coefficient sign And this is just going to be the top bit of coefficient. So coefficient I and 7. Next, the coefficient value. I is going to be coefficient I. We're going to cast it to assigned. And then we're going to take the absolute value of it. Interesting function, right? I wonder how that works. ABS. HDL ABS package. Numeric standard. And it says it exists. So we want to do standard logic vector. And we'll do ABS of that. Okay. Okay. Seems very long-winded. And so let's have an output window, right? Let's do output. It's gonna be an out since we type of window. Okay, get rid of that. Oh, type Windows 16. Okay, never mind. We'll just look at it inside. So yeah, let's just see what the behavioral simulation of this looks like. See if our for loop works the way we expect it to. Restart. Probably put default values on those. I can do that later. We're gonna force a clock. 1, 0, 10. Seems good. Seems good. Seems good. Window. I mean, let's just force a constant. 0, 1, 1, 2, 2. Okay, that sounds good. Now here, let's force a constant. We're going to force 10. We're going to force a constant. Unsigned decimal. We want to do -10. And -1 and -20. -1. -20, run 20 nanoseconds. Okay. Can we change our radix to unsigned decimal? That was hex. And the coefficient sign radix is binary. Okay, yeah, that actually worked pretty well. 0, 1, 2. Okay, so that looks like it's coming along. Let's go back and get a few more stages in, shall we? So first thing, let's put some default values on stuff. And then we gotta figure out how to parameterize it so we can increase the amount of stages. I assume we just add another array here. Make this an array of a different type. And it'd be crazy. We can try that in a minute. Okay. Nope. Here. Here. Can we do like a default value there? Okay. So that's stage 1. Stage 2 is in the same clock, so we can might as well. We'll just do a stage 2 here. Stage 2. Stage 1. So we may need a different type of window for the computation that we're running. Comp 0, 1, 2, 3. So first thing is we want to update the next window. So we want to update the next window. And basically say if so we want to say if CoValue I we need these to be, yeah, this is gonna take a lot. So to carry these values with it, we need to store them. We need to move them along because it's a pipeline. Nothing stays, nothing goes. Yeah, this would probably be a good word to make an array. That should be 0. Okay, so if CoValue 0 equals 1, then and if then coef comp 0 is going to equal that. Right? That look good? Stage 3. So I just do what? So how do we do this easily? So it's going to be this shifted over by 1. Then we're going to have it unsigned. Signed. I guess we can make these signed in the first place. Okay, what are we unhappy about? Oh, some of this. What's that? Shift in VHDL. How do we shift in VHDL? You know what I like to do? I would rather just do, we're shifting to the left. So how about we just do 14 down to 0, right? And we add a 0 in there. Which error is it today? Okay. Let's try stage 3 and then we'll do a simulation to see how this is actually going like we expect. One, two, 13 down to 0, and another 0. Okay. Let's run simulation. Simulation. I'll do 1, and then we'll multiply it by different numbers. So that looks good. Restart. So if we're gonna write a tickle script, let's get a notepad up here. And let's new instance. Okay. So we're going to force the clock. So let's just figure out what command. We're going to force a clock. Start 1, 0, 10 nanoseconds. So we're going to add that here. And our window, we're going to make a bunch of 1s. So let's force a constant on 1. Go over here. 2, 3, 4, 5, 6, 7. 8 of them. Boom. Okay, and now the coefficients. Main 1, 2, 3. I do something like that. Let's not worry about right now. And then force constant 1. May do something like 5, 6, 7, 8. Beautiful. 1, 2, 1, 2, 3, 1, 2, 3. So let's restart. And then we'll need to run this 15 nanoseconds. And let's get what we got here. So okay, we're not apparently not doing 8 at all. 1, 2, 3, 3. 1, 2, 3, 1, 2, 3, 1, 2. Maybe it's because, so it's And we shifted it over 2. And we add it. 0, 1, 1, 2. Oh. Now we're looking at coefficient values. So yeah, this is the window we want to look at. Let's just make them unsigned decimals. We have 6, 7. Okay. Let's so we fix that error. Let us recompile it. Run the code. And we'll see what happens. We're here. Let's run it. Okay, make this full screen. Here we go. We don't care about window reg. What we care about are these radix, unsigned decimal, radix, unsigned decimal. So we need to run another 15 nanoseconds. So 1, 2. This shouldn't be 0 at a minimum. So they're carrying through just fine. And like highlight all of them and say radix unsigned decimal. 1, 2. Oh, that makes sense. 1, 2, and 2, 3, and 3, and then these ones, and it should be added to it. Oh, it is 3, 4, 6. So what happens when it's 0? Oh, we need an else. First one, we add else. Else 0. 1, 2. Now we just need to increase the loop to 8. Let's recompile, go to our script, make it 7. Okay, this is interesting. So it looks like it's working. There we go. 1, 2, 3, 2, 4, 6, 3, 6, 9. Okay, so now we have to do 6 more stages of this, the same thing, and then we have to do a negative stage at the end. It says, oh, if it's negative, we gotta flip the flip it. Okay, so how about, yeah, next I can work on getting the next 9 stages, and we can look at that tomorrow. Or I can work on it real quick tomorrow, get the negative stage going, and then we should have our kernel. Then we need to create it. But we can not worry about synthesis just yet. Okay, yeah, I think that's a good place to stop. Thank you for watching. See you next time.